Hi, welcome back. In this episode, we will discuss the topic of three-dimensional shapes with further discussion on its subtopic, volume. Three-dimensional is an object or shape that has faces, edges, and vertices, with the exception of a shape named sphere. Every object you see or touch has three dimensions that can be measured. The room or space we are in right now is described as three-dimensional shape too. There are a lot of three-dimensional and geometric shapes that are divided into polyhedra, prisms, and pyramids. Let's look at the screen for some examples of three-dimensional shapes. Cube, cuboid, triangular prism, triangular based pyramid, square based pyramid, cone, cylinder, and sphere. Today, we learn about the terminology used to describe three-dimensional shapes and how to calculate their volume. For Year 5, we will only learn about cube and cuboid. A cube is a three-dimensional solid object that has 6 equal faces or sides. It has 3 meeting at each vertex. What is a vertex? Vertex is a corner on a point where lines meet. A cuboid is a solid figure that has 6 rectangular faces or sides. For a cuboid, all angles are right angles and opposite faces of a cuboid are equal. The net of a three-dimensional shape is what it looks like if it is opened out flat, or it can be folded to make a three-dimensional shape. Here is the net of a cube. And here is the net of a cuboid. Now, let us learn about volume. Volume originates from a Latin word meaning size. Volume is the amount of space that a substance or object occupies. It is measured in units of cubic. Why is volume important and what is it used for? Volume is important because it tells us information about quantity, and it is used every day, like how much do we need to fill our water bottle and many more. Let's recap a bit. Look at the screen. The dimension of cube or cuboids are length, width, and height. The volume is the amount of space that a substance or object occupies. How do we calculate volume? Volume is equal to length multiplied by width multiplied by height. Volume can also be found by counting the number of unit cubes it has. For example, question 1. Study the solid shape given. Count the cubes to get the answer. Length is equal to 4 cubes. Width is equal to 2 unit cubes. To get the first layer, we can multiply the length by 2. 4 units multiplied by 2 equals to 8 unit cubes. The second layer is identical to the first layer. To get the second layer, we can multiply the length by 2. 4 unit cube multiplied by 2 equals to 8 unit cube. So we multiply the 8 by 2 to get the whole solid, which is 8 multiplied by 2 equals to 16 unit cube. The volume of the solid is 16 unit cubes. The answer is 16 unit cubes. Question 2. Find the volume of the solid. For this kind of shape, divide it into two simple shapes. A has a length of 2 unit cubes, 2 unit cubes of width, 2 unit cubes of length, and 2 unit cubes of height, which is equal to 8 unit cubes. For B, 2 unit cubes of length, 2 unit cubes of width, and 1 unit cube of height, which is equal to 4 unit cubes. To get the whole, add 8 to 4, which is equal to 12 unit cubes. The answer is 12 unit cubes. What is the total volume of cuboid P and Q? Remember the formula? Let's do P first. For P, the length is equal to 6 centimeters, width is equal to 2 centimeters, and the height is equal to 4 centimeters. So 6 multiplied by 2 equals to 12, and 12 multiplied by 4 equals to 48 centimeter cube. Let's find the volume of cuboid Q. As you can see, there is a hidden measurement of width. How do you solve this? We can use the character of a three-dimensional shape to help us solve the problem. A cuboid is a three-dimensional solid object that has 6 rectangular faces. All angles are right angles, and opposite faces of a cuboid are equal. As we know, P and Q are cuboids. Let's find the opposite faces of the cuboid in order to find the measurement. The equal faces are 2 centimeters. Now, we have all the measurements to find the volume of cuboid Q. So the volume of cuboid Q is equal to 7 centimeters multiplied by 2 centimeters equal to 14. And 14 multiplied by 3 equals to 42 centimeters cube. To find the total volume of P and Q, let's add up. 48 centimeter cube plus 42 centimeter cube equals to 90 centimeter cube. The answer is 90 centimeter cube. Question 4. Find the volume of the solid. The volume of a cuboid equals to length multiplied by width multiplied by height. Simplify the three-dimensional shape. Name the top cube as C and the bottom cube as D. This should be easy as it has an equivalent sign. Just a reminder, a cube is a solid object that has 6 equal faces and all right angles. As we know that a cube has 6 equal faces, the measurement for this solid is 4 meters length, 4 meters width, and 4 meters height. So 4 multiplied by 4 equals to 16. and 16 multiplied by 4 equals to 64. The volume of cube C is equal to 64 meter cube. As you can see, for cube D, the characteristic of a cube applies here. So its length is equal to 7 meters, width is equal to 7 meters, and height is equal to 7 meters. So 7 multiplied by 7 equals to 49, and 49 multiplied by 7 equals to 343 meter cube. The volume of cuboid D is 343 meters cube. Let's add up for the total volume of cube C and the volume of cube D to get the total volume. 64 meter cube plus 344 meter cube equals to 407 meter cube. The answer is 407 meter cube. Find the volume of the following solid. The volume of a cuboid is equal to the length multiplied by the width multiplied by the height. Simplify the solid. Name the top cuboid as G and the bottom cuboid as H. There is a hidden measurement for cuboid G. However, we are given the equivalent sign. So the hidden measurement is 3 meters. Volume G is equal to length multiplied by width multiplied by height. 7 multiplied by 3 equals to 21. And 21 multiplied by 3 equals to 63. The volume of cuboid G is equal to 63 meter cubic. Volume H is equal to length multiplied by width multiplied by height. 11 multiplied by 6 equals to 66. And 66 multiplied by 3 equals to 198 meters cubic. The volume of solid H is 198 meters cubic. The total volume of the solid is equal to solid G plus solid H. 63 meter cubic plus 198 meter cubic is equal to 261 meter cubic. The answer is 261 meter cubic. Look at the diagram. What is the difference in volume in centimeters between cuboid R and cube S? To find the difference in volume between cuboid R and cube S, we need to subtract cuboid R with cube S. But before that, we need to find the volume of each space. Simplify the shape. Volume R is equal to length multiplied by width multiplied by height. 12 multiplied by 4 equals to 48, and 48 multiplied by 7 equals to 336 centimeters cubic. The volume of solid R is 336 centimeters cubic. Volume S is equal to length multiplied by width multiplied by height. 5 multiplied by 5 equals to 25, and 25 multiplied by 5 equals to 125 centimeter cubic. The volume of solid S is 125 centimeters cubic. Let's subtract to get the different volume. 336 centimeter cubic subtract 125 centimeter cubic equals to 211 centimeter cubic. The answer is 211 centimeter cubic. Well, now I hope you can solve the shape and space problem in your examination, yes? Wishing you all the best. Till then, bye-bye.